Hello, everyone. First, I would like to say thank you so much for coming to my presentation and for listening. My name is Montana Riggs. I'm a master's student at Auburn University studying poultry sciences, and today I will be presenting the identification of dead-on-arrival chickens by analysis of body temperature variation. Dead-on-arrival chickens, or DOAs, have become an economic, animal welfare, and food safety concern throughout the entire poultry industry. DOAs can occur anywhere from loading of the truck from the grower facility to shackling prior to stun. These birds cannot be processed alongside birds that have been stunned at the actual processing plant, as they are a food safety concern and must be condemned. Now, plants that utilize controlled atmospheric stunning, or CAS, typically do not give any live evaluation prior to stunning. This is because, as you can see on the right, birds are stunned within the transportation coops during CAS stunning, and therefore the shackling crew is responsible for identifying DOAs by analyzing rigor of the joints when the birds are being shackled. This can be difficult for the shackling crew due to the fact that the line is usually fast, at a high speed, and the birds need to be shackled as quick as possible. In some CAS systems, the entire transport truck is stunned prior to shackling. This is instead of the usual method where coops are put through an actual CAS system and then they are stunned throughout their individual coops. Now, before I go any further, I'd like to give a little bit of backstory about how this problem and this project came to be. We had a spent broiler breeder processing company approach us and tell us that they had a controlled atmospheric stunner for their full truck. Now, it had no problems. The CO2 was circulating properly, the birds were being stunned, and it was completely functional and already built. So what was the problem? Well, their problem was the fact that all birds were being stunned without any prior checkings for DOAs. So they had no idea if they had any DOAs on that truck before they had actually stunned the rest of the birds. Now, the problem goes further than that. They also noted that when they were unloading this transportation truck, it took about 120 minutes in certain circumstances to unload the final coop into the shackling processing center. At this point, it wasn't really sure if rigor was applicable as a method of differentiating which ones were DOAs compared to which birds had been stunned on that truck, as the birds that had been stunned on that truck for 120 minutes could be just as stiff as the birds that maybe had died an hour prior to stunning. Therefore, we needed to think of a solution on how to differentiate DOAs from birds that had been stunned on that truck. The solution we thought of was the possibility of analyzing body temperature variation among coops in order to see if any temperature differentials were seen with these birds. Now, it's important to note that DOAs have various times of death, as mentioned previously, and they could have different coop conditions, such as a different number of coop mates, or location of the DOA itself. As you can see on the right, I've circled that there could be a very crowded coop, and therefore their coop mate's ambient body temperature could keep that DOA warm. There are also whole truck controlled atmospheric stun birds that take longer from stun to shackle, as mentioned previously, and therefore that is why I would like to make sure that we look at an overall differential in body temperatures rather than just a temperature of DOA itself. The objective of the study was to evaluate body temperature differentials for identifications of DOAs. For study number 1, we had used broiler breeders. There were 24 transportation coops containing 8 to 9 spent broiler breeders. For this study, we used the Fluke 76 max thermometer in order to gain temperature data analysis and to gain temperature data on each individual bird. Now, for our second study that we performed, we used broilers instead of broiler breeders, and we also used 24 transportation coops. However, these coops all contained 7 broilers each. For gaining temperature data, we used the Fluke 76 max thermometer as well. However, we also used the Seek thermal imaging camera. The Seek camera, as you can see all the way to the right, was a small device that plugged into your phone and allowed for us to be able to take quick and convenient pictures. Below are the 2 pieces of equipment we used in order to capture the temperature of each bird. On the left is the Fluke 76 max thermometer that was mentioned before, and on the right is a Seek thermal camera. On the left, you can see that my finger is on a green trigger on the back of the thermometer. This allowed for us to hold the trigger as we put the bird on its back and scan the whole bird. If we held the trigger down while we were scanning, the thermometer would tell us what the highest temperature was at any point of scanning while we were holding the trigger down. On the right, you can see the Seek thermal camera. This camera allowed for us to have a good visual representation of where the hottest point of the bird was. It also allowed for us to have a setting where we could see and it would point out that exact location of the hottest temperature on the bird. That way we could take some good pictures and we could be able to see where usually the birds have the most body temperature left after they are dead. Now I'd like to go over our experimental setup. On the left, you can see we have our DOA time. In order to represent that, we took one bird from within each coop, euthanized that bird, marked the bird, and then put the bird back inside the coop. We then waited either 15 or 120 minutes. This time was predetermined before the bird was actually euthanized. This represented how long the DOA would have been dead on that truck or in the lairage area before the controlled atmosphere stunning stage. Now, in order to represent the controlled atmospheric stun, we euthanized the remaining coop mates and put them back in the coop as well. We then waited 15, 30, 60, or 120 minutes before the shackling stage. This time in between the controlled atmospheric stun stage and the shackling stage represented how long it could take for all birds within the truck to be put into the actual shackles within the plant. At the shackling stage, all temperatures were taken. And this is where we use to find the differentials between the DOA and the differentials between that and the coop mates. I'd like to point out that at 5 minutes in between the controlled atmospheric stun stage and shackling stage, this represents the actual controlled atmospheric stunner that we would see in a plant, not a full truck atmospheric stunner. This way, we can see if we can have temperature differentials between either or methods. Typically, it only takes max 5 minutes after the birds have been put in the stunner until they are put on the shackles. We also waited 120 minutes, and this represented what I was talking about earlier when it said it could take 120 minutes for the whole truck to be unloaded. For our statistical analysis, it was performed using SAS University Edition. In order to analyze differences between the means, we used a one-way ANOVA, and in order to separate the means, we used two-piece t-test. The results were considered significant, but the p-value was less than 0.05. Now for our results. First, I'd like to go over our broiler breeders using the temperature sensor. On the x-axis, we have our DOA time times our time post-stun in minutes. On our y-axis, we have the average body temperature amongst the coop mates from the highest point of their body temperature. So it was the average of the coop mates, but the highest point of the coop mates. The x-axis, we have our DOA time. That represents this part of the stage here, where we euthanize one coop and replace that bird and put it back in the coop. On the x-axis, we also have times the post-stun time. That represents our controlled atmospheric stun stage and the time waited after until all birds were shackled, or represented of birds being shackled. Our blue bars represent the DOA's average body temperature, and the orange bars represent our coop mates. Now, this is analyzing study number 1, where we use broiler breeders and only the temperature sensor. For our broiler breeders that had a DOA time of 120 minutes, we could not tell the difference between any of the birds that had been fully stunned, except for when birds were stunned, and then we waited 5 minutes until taking temperatures. So this showed that we could prove significant results when simulating an actual controlled atmospheric stunning setup rather than a full truck setup. However, we could not prove that we could see any difference using a temperature sensor for 120 minutes, 60 minutes, or 30 minutes. Now with a DOA time of 15 minutes, we actually did not get any significant results using our temperature sensor. Now, this is the start of study number 2, where we use broilers and the temperature sensor first. For a DOA time of 120 minutes, we found significant results for any stun time in comparison to any stun time for the rest of the coop mates if the coop mates have been dead for 120 minutes, 60 minutes, or 5 minutes. Now, I'd like to analyze here that and take the point that even though the third set of bars does not have any significant results, the p-value was 0.0562. So while it wasn't significant, it was following the trend that we'd like to see. Now, for broilers with a DOA time of 15 minutes, utilizing our temperature sensor, we did not find any significant results when comparing them to the body temperature of the rest of the coop mates. For broilers, when we used our infrared camera or the seat camera mentioned before, when we had a DOA time of 120 minutes, all stun times for the rest of the coop mates were able to be analyzed for differentials that were significant enough to say that the DOA bird was significantly different than the rest of the coop mates. Now, the same as before in the following trends we'd seen, for the infrared camera, the DOA time of 15 minutes was not considered significantly different from any different stun time for any of the other coop mates. Now for our discussion. We were unable to differentiate DOAs from coop mates when the DOA time was 15 minutes. This is true of all different treatments and studies. So broiler breeders, or temperature collection methods of thermal cameras or temperature sensors. It would be valuable, however, to determine what the shortest distinguishable time would be, if not 15 minutes. What time could we actually start to see a distinguishable and significant result between the coop mate's body temperature and the DOA's body temperature? Using temperature differentials for identifying DOAs shows potential for a new evaluation method, as we did see some significant results and get some significant data from DOAs that were dead for 120 minutes. For future applications, I would like to include rigor testing as a method of also comparing results to the temperature variation. So could rigor testing still possibly be applicable instead of having to use body temperature? Well, in comparing our results and our statistical analysis of our body temperature results, I'd like to have someone test the rigor as well and see if we can notice a difference or if any is better than the other. I would like to also add additional DOA timeframes and possibly have a 20-minute, 30-minute, or any other longer time period to be able to find that shortest time period where we can start to get significant results in analyzing our DOAs compared to our coop mates. I would also like to look at whole truck turkey stunning, as whole truck turkey stunning is actually much more common than whole truck broiler or broiler breeder stunning. And I'd love to give a huge thank you to the Auburn University Poultry Department for the opportunity and for the resources to make this study possible. I'd also like to thank the Barasa Lab for all the help provided in collecting this data and making the study possible. If you have any questions for me, feel free to email me here at mrr0058@auburn.edu or to call me at my number listed there. I'm also happy to answer any questions throughout the PSA conference. And if you have any messages or any questions or concerns, feel free to let me know. I'd like to say thank you so much for coming to my presentation. I appreciate you guys listening to me, and I hope you have a good rest of your conference.